Hi, in this recording we're going to cover the topic of how to deploy a Tanzu Kubernetes Grid Cluster using the Cilium CNI. In this recording we're going to start off with getting hold of our Cilium and Hubble CLI tools. We're going to create a Tanzu Cluster YAML file which has the specific CNI configurations to allow us to install the Cilium CNI. We're going to deploy that Tanzu Kubernetes Grid Cluster with Cilium. Then I'm going to install Metallb so that we can then use a demo application so that we can show just external connectivity into the environment, but also then we can observe some of that traffic from the demo application using the Hubble observability tools that come as part of Cilium as well. So we're going to start off on the documentation page for Cilium, so docs.cilium.io, and then if we go to the Getting Started guide and then quick installation, you're going to find the details to install that Cilium CLI tool, and that's what we're actually going to use to bootstrap into our cluster, the CNI itself, when our Tanzu cluster is waiting for those network configurations. And it also be good if you could go down to the observability page here, and I've got that open in another tab, and then scroll down a little bit and you'll also get the details to install the Hubble client CLI tool as well, which gives us that observability data from the Cilium CNI so that we can monitor our applications as well. For this recording, I have a vSphere environment where I've already deployed my Tanzu Kubernetes Grid Management Cluster. So now we're going to prepare to deploy our Tanzu Kubernetes Grid workload cluster into that environment. So I'm going to change into the hidden config folder under the Tanzu folder on the TKG and then cluster configs. And then we need to create another file so that we can set the CNI to none in here, which is basically telling the cluster when it boots up to not install a CNI at all. So the options are Entree or Calico out of the box. And then if you need to bootstrap a different CNI, which you have the ability to do from VMware, then you set it to none, and then as part of that build process you manually provision this yourself. So that's what we're going to do now. So I have already created one earlier, so what we're going to do is it's called CNI test2.yaml. I'm just going to open this out, and we can see here I give it my cluster name, but the most important piece that I've added in here is that line CNI colon space and then none in lowercase, and then all of my other information here essentially stays the same. Okay, so let's move on and get that set up. So I'm going to clear that screen. So we're now going to see the Tanzu Cluster create command, and I'm going to call this veducate tkg Cilium, and we're going to pass that file through, and it's CNI test2.yaml, and then we're going to see that it goes off validating that configuration, and then we'll start to create the virtual machines in my vSphere environment, and then it will start to bootstrap that CNI. What we're actually going to see though after a couple of minutes is that the bootstrapping doesn't continue any further. So actually this command that's in place will never actually complete, and the obvious reason behind that is our Cilium CNI is not installed, so we'll actually need to control and break out of this once so that we can install that control plane. Okay, so we skipped ahead about 3, 4, maybe 5 minutes, and I'm going to cancel out this command. So actually deploying this into a VMware Cloud AWS environment, so it should be pretty fast to spin up, and it's a small size cluster as well. So I'm going to cancel out that, and let's have a quick look at what's actually happening when we inspect this cluster that's being created. If I do the Tanzu cluster get veducate tkg Cilium, we can now see here that it's creating, but the control plane is still 0 of 1, and the work is 0 of 1. And we can see here that it's waiting for available machines, and that's obviously because that CNI isn't set up yet, so it can't continue the rest of its bootstrapping. So let's do that now. So the first thing that we need to do is we need to do Tanzu Cluster kubeconfig get, and then it'd be veducate tkg Cilium, and then we'll do the -admin, and then we can see now that it's created it saved that context for us. So let's now change into that. Okay, so if I just quickly clear down from there, and I'm just going to change my CD back to home because I don't need to be in that folder anymore. So I'm using a plugin here to actually display some information to remind me the context that I'm in as well, if anyone was wondering about that. I think it's called cube on cube off is the command. I think it's cube ps is the plugin installation if you stick that in Google or GitHub. So to install Cilium, it's really easy. So we're just going to do the Cilium command line. So I've already installed that earlier. I showed you at the start of the video where to get that from. We can just do a quick Cilium version. So you can see here, it's giving me the version, but it's letting me know that there's no pods actually found on the cluster that we're connected to. And we're just going to do Cilium install. And it auto detects cluster, and then in the background it uses Helm to deploy all of this with certain parameters in place, which is great. And that'll take 60 seconds to a couple of minutes just to install, because it needs to download those pods and so forth into the cluster and then get them all running as well. Okay, so that probably took about 2.5 minutes for me, and it will also restart any unmanaged pods that it needs to as well to put it onto that CNI level. So now if we go back and I get that Tanzu command, so if we get that, we can now see that we've got running for our control plane 1 of 1 and our workers as well. And one of the great things with the Cilium tool is it also has some status checking in there as well. So if I do Cilium status, we can now see that the Cilium operator is installed and showing is okay. I can see the details about the daemon set, which means it's going to run pods on every single node. We can see the deployment itself of the operator and the containers running as expected. So the first thing I'm going to do is validate the installation through a connectivity test. So I'm just going to move that up slightly because you can't see the bottom there. So we'll just clear all of that text again. So again, with the Cilium tool, it makes it really nice and easy. It has a connectivity test built in, so it's going to download these from I think it's a GitHub repo, possibly using Helm again. We might actually see that in the deployment, and it's going to figure out the architecture of the cluster that you are pointing it to and run the necessary tests as well. Oh, so what have I spelled wrong there? So Cilium connectivity. Oh, I did the word test, and it's not. So let's do the word. There we go. Test. So again, it's going to do very simple things. So it creates a namespace to run a load of YAML files and configurations into, and then essentially when we look at the pods, we want everything to be completed, and that's how we know it's done as well. But the great thing with the tool is it's going to interpret that for us and actually give us a status output at the end as well. Okay, so that probably took about 4 or 5 minutes as well to run all of those tests. So at the moment, as I mentioned, if I do kubectl get nodes, I've actually only got a 1 control plane, 1 worker node environment at the moment. So let's actually scale that up. So now we've got the Cilium operator in place. When we scale the cluster, that means it's going to deploy all the necessary pods, configure Cilium to work with that as well. So we're going to scale this to 2 worker nodes. And we can see that it's being scaled at the moment. And as you know, with Kubernetes, everything's declaratively, so it'll just kind of wait till that comes available. So if I do the Tanzu Cluster get, let's get TKG Cilium. We're going to see there again, it's waiting for available machines and it's now going to 2. So we're just going to leave that for a moment or 2 to kick through. But what I will do is I'll do a kubectl get node. I'm going to add the watch command on that as well. And just wait for that extra node to come available. Okay, there we are, that extra node there. And if we go back to that Tanzu command as well, we can see it's all there. And then again, if I do the Cilium status command, we can now see that this has increased. We've got additional cluster pods there. We can see that Cilium containers have gone to 3. We can see that the desired for the daemon set has gone to 3 as well. So that's good news. And then what we're going to do one more time, and we'll make this a little bit faster for the recording, It's just going to run the connectivity tests as well. But for the Eagle Eye Gamunju, what you'll also notice, because there's now an extra node in there, it's going to run a couple of additional tests. Okay, so that's all completed successfully again, which is great to know. I think it's always possibly worth doing that when starting to scale things up. So the next area we need to focus on is I'm going to install Metallb, so that's the very popular Kubernetes-based load balancer, so that we can then deploy my demo application, so that we can just test some connectivity and see some of those observability tools as well. So I'm actually going to use the version 0.12 of this for Metallb. I actually found in my testing that when I was installing this with the latest 0.13.5, traffic wasn't passing into the load balance services for some reason. I'm not entirely sure why that was. So I went to the GitHub repo for Metallb and I went back a version, tested that, and everything worked fine. So it's an area where I've got to kind of open up a ticket with the team there and see if they can get to the bottom of that one. So once we've kind of made sure that all our pods are running, so we're going to do kubectl get pods in the namespace of metallb-system. So we can see that if it kind of just coming up there, it's the speakers just getting ready to be running. But we also need to create a config as well to what IP addresses it can use. So we just need to add some load balancers in for Metallb to use. We're going to do that through a config map. So I've got this here. So I'm going to create a config map in that Metallb system, and then basically these are my address app and make it available to the environment. So apply that. So that's created, and we'll just clean that up again. Okay, so that's Metallb up and ready and waiting to go. So the next thing I'm going to do now is going to install my Pacman application. Now, usually I do it from my own GitHub, but one of the very smart guys over at Kasten by Veeam actually saw the Pacman application that I was using and working with the likes of Michael Cade with. He's taken the original source code that was online with that, updated the inside the Node.js and the JavaScript and so forth, repackaged that into his own container, hosting that himself through Artifactory, I think it is, and then he's also created like Helm installs for that as well. So I really recommend you go to the blog and have a look at that as well. I was going to add in his Helm repo there as well. So as you can see, I actually already had that added in. I'm going to do a Helm install. So we're going to install Pacman into the namespace Pacman. So let's create that namespace for us. And then we also want to set the service type as load balancer. Okay, so that was pretty quick, which is good. So we can see here we can watch the status of there to get the service, and then we can get these IPs as well. So I'm going to run these two commands here, and then we can see I've got this address for my environment. So if we curl to this, and we might not quite get a response just straight away. Nope, so that's fine. So I'm going to clear that down again. So we're going to do kubectl get pods in the namespace of Pacman. So we can see that the front end is now running, but the Mongo database backend at the moment is still initializing. So that's going to take a little bit longer to go ahead. So we'll just put a watch command on there. Okay, that's all running fantastic. So if we go up and I try and curl this, there we go. We can see now that I'm getting my Pacman response as well through curl. So let's have a look at this in a little bit more detail. So in the UK we have something called Blue Peter. Let's call our Blue Peter one. Here's one I made earlier. So this is my lab environment, which is where I've got access into this. So we're going to create some traffic here. And the reason why this is really important is because I want it to come from my machine, and I shouldn't have had that. I wanted to die a little bit quicker. So we're just going to wait for that effect to wear off on these, and then we're going to kill myself there. There we go, and we're going to save that as VHK. I'm going to save that, and it goes into the database, which is fantastic. So now I've actually created that traffic, I want to view some of this data. So we're going to install the Hubble. So we'll get rid of that again, and we'll clear that screen. So we're going to do that by doing Cilium Hubble enable, and then we're going to do -UI as well, because I actually want the UI pod to be started so we can expose that and connect to it as well to get some visualizations, not just through the CLI tool. So we'll do that again. You can see it's very similar to the other Cilium install where it uses Helm templates and passes through the relevant parameters to that. And then it's going to download the necessary components and configure that for us. Okay, and if we go back to that Cilium status command, we'll actually see as well that it picks up Hubble there as available, and we can see now as well it's telling us that the extra contains there things like the Hubble relay and the Hubble UI as well, which is fantastic. So we'll clear that down. We've actually already installed our Hubble tool as well, so I've already got that here. So if I do Hubble version, and also as well the Hubble command has a, it does have a status command, but that's not going to work at the minute. And the reason for that is because we need to port forward on the API address, which is port 4245, or you can specify that with, I think it's the server command to connect on a different API as well. So there you go, so you can set the config there. Go back to the Cilium documentation, that'll explain all of that for you. So we're going to do Cilium Hubble port forward, and I'm going to put an ampersand on the end of that as well so it keeps it active and running. And now if I do Hubble status, we can see that health check is connected via the localhost within that Hubble expose, which essentially is just exposing the service using kubectl in the background there. You see the amount of flows that have been detected by the system, how many flows coming in or have been recorded per second, how many connected nodes there are in detail. So now we've got that working, I can do the Hubble observe command, and then I can also add a namespace to that as well. So I'm going to add n, and I'm going to add pacman in there. And then we can see all of the system. So we can see from the node going back and forth here between the services. I can see pacman itself running, going and writing that data back to the Mongo backend as well. So that's really good because we know I saved something there previously. And if I go back to my desktop machine, so if we just kind of run that again, and it keeps keeping it a bit active, and I'll move that out of the way. And if I Hubble observe there as well, what we should be able to see is coming in from the outside world space, just more traffic going in there as well, which is great. And we can say whether that's over the overlay to an actual endpoint, what the traffic there was, and also the TCP flags of that traffic as well. And then the next thing that we want to do is we want to actually access the UI itself. So I'm going to clear that. I'm going to copy this command from the blog post to make my life easier. But essentially, we're going to patch the service called Hubble UI into the namespace of Cube System, and we're going to change it to type load balance. So actually, before I do that, let's have a quick look at that service. We'll do kubectl get service in Cube System, and you can see that it's there, but it's actually set to cluster IP at the moment, so it's still not accessible from the cluster itself. So let's change that. So now if we go to get service, we can see that this has been made available on my external IP address. And now if I go back to my desktop machine, so what I'm going to do is this when I had it open previously, so I'm just going to go to the 41 there. This is the Hubble UI. You can see to get beginning, tells you select a namespace, so we're going to choose pacman itself again, which is brilliant. And now we can see all of the pacman traffic that's been brought in. And as well, if I start to click around this, because it's my service dependency mapping that it's showing me as well, I can then start to find more details there, but you can also see it's showing to and from this particular identity. If I go to the pacman backend there, so that database, there's only kind of one-way traffic, so that then means that we lose that outside world view as well, and it also then will curate this traffic at the bottom for me here, and I can see the timestamps and details of the verdicts, and basically mirroring what we saw in the CLI tool previously. If I delete that, I can go out, and I can see the world coming into the pacman as well, and then same type of details there. So that's it. Kind of wraps up our demo of installing Cilium into a Tanzu Kubernetes Grid Cluster, deploy that application, generate some traffic, and use some of those observability tools as well. And from here, you can kind of go through some of the other Cilium documentation and start to create things like some of their advanced networking security configuration as well. And if you've got multiple clusters, you could even do something like the cross-cluster service mesh as well. Thank you very much for your time.